Howdy y'all, I hope you've been good. I'm here finally with a new chemistry video, and today I'm going to be making 3 different copper compounds. The reason I'm going to be making these compounds is because I recently developed a little theory as to the oxidation of copper metal by acidic peroxide solutions. Recently, I've been talking with my chemistry professor about my little theory, and he recommended I do a few reactions. So the reactions I'm going to do today are copper metal with either solutions of acetic acid, hydrochloric acid, or sulfuric acid with added hydrogen peroxide. But before we get into that, I would just like to say thank you for joining me on my quest here to become a chemist, and also in joining me for my shenanigans. And I would also like to ask you to leave a like, comment, and subscribe if you haven't done so yet. Thank you, and let's get into it. So I'm going to start off by weighing out 1.8 to 2.2 grams of copper. So I weighed out the copper, and I was able to put in almost exactly 1.8 grams of copper into each beaker. So in my large beaker, we'll go hydrochloric acid. In my medium beaker, I'll put sulfuric acid, and in my small beaker, I'll put acetic acid. Here comes hydrochloric acid. Now I'm going to dilute the hydrochloric acid with hydrogen peroxide, 3% hydrogen peroxide, just one you can get at the store. I need about 36.95 milliliters. I'm going to go ahead and start putting that in here. Now I'm going to dilute the sulfuric acid. I need roughly 38.15 milliliters. So I'll just go with 38. That should be good enough. Let's pour it in. I already poured in the hydrogen peroxide into the hydrochloric acid solution, and immediately the reaction began. As you can see, it's already turning white. Blue. The sulfuric acid one turned white. That's odd. Anyways, let's watch and see what happens. So now I'm going to introduce my theory, and again, this is just what I've created based off of my observations, off of what I've learned. I have no guarantee that this is, correct or accurate. So let's review it together. So copper plus hydrogen peroxide. First off, the oxidation state of the oxygens and the peroxide anion are -1. So we can see that since there's two oxygens and the net anion has a charge of -2, that means each oxygen has a charge of -1. So that just helps us later on. Moving on. Oh, how do I? Okay. So I believe that the peroxide anion pulls on copper's outer electrons but doesn't actually take them. So if you look at the little drawing that I drew, you can see that the peroxide species is kind of yanking on those electrons, on copper's electrons, and we can see that that creates a partial negative charge. So the peroxide takes electron density away from copper. Let's move on. In acidic solution, hydrogen ions become attracted to the partial negative charge of the copper and migrate towards it. So as you can see here in my drawing again, we have the copper with its electron field being basically pulled towards the peroxide, and now there's two hydrogens being attracted to the partial negative charge of the copper on that one side, and they're migrating towards it. So, and then this one's in text. So, the copper, already having its outer electrons being pulled away by the peroxide species, can no longer hold onto its outer electrons when H plus is introduced. Subsequently, two H plus species each gain one of the copper's outer electrons. So again, if we look at the drawing, we can see that the two hydrogen ions as well as two electrons are being paired up, and ultimately that yields a copper 2 plus ion as well as hydrogen gas. There was one last thing I needed to share with you. Since hydrogen peroxide does not meaningfully dissociate, the negative charge of the peroxide anion does not repel copper's electrons, as peroxide's charge is cancelled out by the two hydrogen ions attached to it. The peroxide species is capable of pulling electron density away from copper, as each substituent oxygen in peroxide is in its -1 oxidation state, which is what I showed you earlier that I calculated. Each substituent oxygen wants to be reduced to their -2 oxidation state. The effective nuclear charge of each O negative in the peroxide anion likely contributes to its tendency to pull electrons away from other species and towards itself. So what you're looking at now is actually the control reaction. This one is only copper metal with hydrogen peroxide. And I've actually had this one running for the past 2 to 2.5 hours, though unfortunately I only just now started recording it. But the only observation I have been able to make is that there are these bubbles that are forming. Let me bring it up to the camera a bit more. But there are these bubbles that form along the sides of the glass, but as well as on the metal itself. Let me see if I can... You can see it there. So far, I have not noticed any blue coloration. Any blue coloration of the solution would indicate that there are copper 2 plus ions in solution. So I will have to interpret these results later. I can't give you a definitive, oh, this proves my theory or this disproves it. But I would also like to show you the final results of the other 3 reaction solutions. After about 8 hours of reacting, they have been fully reacted. Let me get this one out of the way. I'll start off with the copper plus hydrochloric acid and hydrogen peroxide. So that would be this one here. It's very blue, I would say sky blue. In real life it looks more sky blue, although on camera it does appear almost neon. And there's still some unreacted copper there because there was just an excess of copper. And there's also this powder at the bottom, which I believe might just be copper 2 chloride that crashed out of solution because I think it's already saturated. So this was the copper plus hydrochloric acid and hydrogen peroxide. Now I'm going to show you the reaction with sulfuric acid and hydrogen peroxide. So again, very, very blue. Let me take off the lid so it doesn't interfere with the color that you see. Very, very blue. Oh, that didn't work. In real life, they appear more blue than they do on camera. But again, you can see that there's some unreacted copper because, again, the copper was an excess. And for both of these, it's a clear sign that by the addition of the hydrogen peroxide, that the acid can react with copper, which normally it would not. So now let me show you the copper 2 acetate. This one's harder because it's almost filled to the brim, so I need to be careful not to spill it. In person, I would say this definitely has the most brilliant blue color of the three. But unfortunately, you cannot see it very well on camera. And again, the fact that it's blue, and we can see that some of the copper has obviously dissolved, is evidence that the hydrogen peroxide allowed for the oxidation of the copper metal, which allowed it to actually react with the acid, which under normal circumstances, without the oxidizing agent, there would be no reaction with these acids. Well, that brings me to the end of the video, and I would just like to again thank you for joining me here, and I would also like to bother you again to please like, subscribe, and comment. It would mean the world to me if you did. And I promise that this time I will actually post a video sooner. I'm actually going to post a follow-up to this video maybe within the next week to week and a half. What first I'm going to do is I'm actually going to boil away the solutions to be left with the salts as crystalline solids. But I'm also going to try and interpret the data that I collected, as well as speak to my professor, as well as some other chemistry professors at my school to see exactly, if my theory has any merit to it. And once more, thank you so much for being here. Thank you for watching, and I hope you have a really good day.